The best way to learn networking is just to do it. Even if in the beginning it's a little bit confusing or doesn't all make sense, you'll get this if you just keep on learning and you keep on trying to build networks. Packet Tracer is a great way to do this. So in a previous video, I showed you how to connect two laptops and a server to a switch. I showed you the services running on the server. So as an example, if I go to services here, we tested the HTTP and HTTPS service running on the server. We were able to connect, for instance, from a laptop, opening up a web browser to the server. So as an example, 192.168.1.3, the IP address of the server, I was able to view the website running on the server. Now, let's look at the switch because we haven't really done much with the switch. So in this example, I've got a physical switch, but in Packet Tracer, we've got a switch here. So if I click on the switch and go to CLI, the switch will boot up and then display something. So actually, let's do that whole process together. So what I'm going to do is close Packet Tracer and save the file. I've saved that to my desktop. I'll double click on the Packet Tracer file to open it up in Packet Tracer. And there you go. I'll zoom in a bit. These links show orange because the switch is running a protocol called spanning tree protocol that blocks loops. We'll cover that in a lot more detail later. For now, notice if I click on the switch, go to CLI, the switch boots up. Very, very quick here. But if I scroll up, you can see it says booting and it boots right up and then shows some Cisco information. You can see Cisco Systems Incorporated shows that it's running what's called Cisco iOS. iOS is essentially the operating system of the switch. Over here, I've got a Windows computer. So as an example, I could say WinVer to see Windows information. You can see it's running Windows 11 with version 23H2 at the time of this recording. That is an operating system. On this phone, it's an Android phone. So it's running a specific version of Android. Or here's an iPhone running iOS. Cisco devices run their own operating system. So this is Cisco iOS. It's not iOS on a phone, but it's the same idea. It's an operating system that's used to manage the switch. It boots up, bunch of information is shown. If I press enter, we're told here, press return to get started. Now, if it's a brand new switch, it'll actually say, do you want to enter the initial configuration dialog? And it didn't do that here. So if it does ask you that, just say no. You don't want to enter the initial configuration dialog, and then you'll see this prompt called switch. So what I'll do is just force the switch to do that. So don't worry about what I'm doing here. I'm simply removing the config of the switch and I'm going to reload it. As you can see here, the switch is now booting. This is the process of it booting up. And at the top here, we can see system configuration dialog, press enter, and it asks me, would you like to enter the initial configuration dialog of the switch, yes or no? So please don't worry too much about the commands that I typed. Scrolling right up here, we can see that I typed erase startup config. That basically resets the switch to its factory defaults. And then I use the command reload, which is basically rebooting the switch. Again, don't worry about that for right now. We're going to cover that kind of stuff in a lot of detail when we get further into the course. What I want you to see here is it says in system configuration dialog, and it asks us, do you want to enter this? Yes or no, multiple times. Here it does again. So if I press enter, it keeps asking me that. I'm going to say no. And then it says press return to get started. And I'm going to press enter. I am now connected to what's called the console of the switch. Now in the real world, you can't just press enter on a switch and get access to it. You need to connect to it somehow. And the way we did that in the old days was using what was called a console cable like this. So we'd have a cable like this connected to the COM port of a PC, and then this interface, which is also RJ45, similar to Ethernet, but this is not an Ethernet cable, would be connected to the console of the switch. On my old laptop, once again, I would take this connection and connect it to the COM port of the laptop, and then I would connect this to the console of the switch. These modern switches don't have that connector. But here's an example with a 1000 series Cisco switch. Notice I can connect the cable over there. So again, I'm connecting from the COM port of the laptop to the console port of the switch. So when the switch boots up, I'd open up an application called PuTTY as an example on Windows that would give me a console connection to the switch. Now again, we don't typically have laptops today with COM ports. That's an old way of doing it. So what we typically use today is a COM to USB converter like this, and then I would be able to connect the console cable to a modern laptop. So as an example, I would connect it to the USB port on the laptop, and then I would be able to connect this part to the switch. But again, a modern switch like this doesn't have those ports. That really depends on the switch or the router. I'll show you this in more detail later. For now, I just wanted to show you that I can get to the console of the switch and then look at stuff on the switch. On a modern switch like this that doesn't have a RJ45 connector, you would have to use, for instance, a micro USB connector like this, which would connect to USB on the other side. So on my laptop, as an example, I would have USB on the one side and micro USB on the other to connect me to the switch. This is not Ethernet, this is USB. And then what I can do is find an application called PuTTY. So in my browser, I'm going to go to Google and search for PuTTY. First hit is putty.org. Second hit is this org.uk website. That's the one I want. So I'm going to go to that link. I'm going to click download it here. And notice you can download the MSI installer, or what I'm going to do here is simply download putty.exe. That's now downloaded. It's very small, 1.6 meg in size. So I'll double click on that file. When it starts up, it'll look like this. So here's PuTTY on the right. Here's packet tracer on the left. So if I press enter, you can see we've got packet tracer on the left. But on the right, what we need to do is connect to what's called a COM port. So I'm going to right click here and go to device manager and look at ports COM and LPT, and you can see here's COM8. So what I'll do here is specify COM8. I'm going to leave the speed, etc. default. So I'm opening up a serial connection to the switch. Remember in the old days, we were using a console cable like this. I'll show you those kind of options in more detail in a separate video. But for now, I'm going to click open here and notice it says initializing hardware. And if I press enter, you can see I'm on the console of a 9200CX switch. So here's a packet tracer switch, and here is a real physical switch that I'm connected to. So in packet tracer, we can type commands just like you would type on a real Cisco switch. As an example, if I press question mark, I see various commands. On the physical switch, press question mark, I see even more commands. Now, when you see more, you can press enter to show one line of output at a time. So that's one line of output. If I press spacebar, that shows one page of output at a time. Packet tracer doesn't have that many commands here, so I didn't have to do that. If I press question mark in packet tracer again, I only see a small number of commands. In the real switch, if I press question mark, I see a whole bunch of commands, and I can press spacebar to see a whole page there. Now you're going to get really used to the Cisco CLI or command line interface. That's what this is. We're going to talk about Cisco CLI and Cisco iOS. The iOS is the operating system. This is the way that we configure Cisco switches. In the beginning, it can be really daunting, really challenging, but you're going to get used to this as we go through the course. By the end of the course, you're going to be very familiar with this interface. First thing you need to take note of is this greater than sign means we're in user mode. There are a limited number of commands available in user mode. You can't configure the switch. You don't have a lot of privileges. You can basically do some show commands to see information about the switch and then move to a more powerful mode or privileged mode. Same thing here. You can't do much with a switch. One of the commands you can use is show version. I'm just going to type it manually, show version, and press enter. And that shows me the switch that I'm working on. So in PuTTY, I could make this a bit bigger and scroll up. There is the command that I typed. Here's the output of the command. You can see this switch is using what's called Cisco iOS XE software. This, once again, is the operating system of the switch. In packet trace, if I type show version, again, I can see information here. So if I scroll up, what you'll notice, quite a bit of output here. There's the command that I typed. This switch is saying Cisco iOS software. And then here it's saying XE. Packet trace is great software, but it's not perfect. It's not going to show everything the way it should. Hence me using physical devices to show you what it actually looks like. But it gives you a really good idea. Scrolling down here, we can see the version of operating system that was used. It's booting off what's called flash. Think of flash as the hard drive, just like you have a flash hard drive in a computer. This is the hard drive of the switch, and that's where the operating system is stored. It's a bin file, a binary file. So when the switch boots up, that's the file it's booting to load the operating system, just like Windows will boot off the hard drive, or the phone boots its operating system. Same kind of idea. On this switch, if I press spacebar, whole page of output is displayed. Spacebar again, whole page of output is displayed. So whenever you see more, you can press enter to see one line of output, or spacebar to see a whole page of output. A lot of information here. You don't need to know all of this. Again, scrolling up, there's the command that I typed, and we can see a whole bunch of information, including, as an example, how long the switch has been up for. So it's been up for 3 hours and 39 minutes. On this switch, it says uptime is 7 hours and 33 minutes, which is not correct. This is just fake information on the switch. I mean, I didn't call the switch test. So it's fake in Packet Tracer, but gives you an idea of what's going on. Here we can see license information about the switch. We won't worry about that now, and a whole bunch of other output. All I want you to know for the moment is this is called user mode. I can type certain commands here, but I can't configure the switch. Question mark shows me the commands that I can use. So I use this command show to show information about the switch. It says show running system information. On a real Cisco switch, if I use question mark, press spacebar here, notice that is correct. Show running system information on the switch. We can do other commands here, like as an example, ping. So we could ping from the switch, but this is very limited. From user mode, you want to use the command enable to go to privilege mode or enable mode. Now, please note, be lazy. Learn to be lazy with your commands. I could type enable, the full command, or I can just type en and press tab, and that will complete the command. This is similar to Linux as an example, where you have autocomplete of a command. So tab autocompletes. On the physical switch, type en, tab. Now what I can do on Packet Tracer as an example is press enter, and notice the output has changed here. The mode has changed. We see a hash or pound sign if you prefer. On the physical Cisco switch, type enable. In this case, I have a password configured on the switch, so I'll put that in and press enter. Notice the mode has changed. New switch in Packet Tracer doesn't have a password configured, so I went straight from user mode to enable mode by using the command enable. I can go back by typing the command disable, and notice I'm back in user mode. On this switch, I had a password configured, so I had to put that in first, but I could also type DISA tab now, and the command is auto-completed, and that takes me back to user mode. You're going to struggle in the beginning with these modes. You're going to type commands and they don't work. So as an example, if I type the command conft here, the switch doesn't accept that because I'm in the wrong mode. You have to be in the right mode. So if you have a problem where it says invalid input detected or something's wrong here, the command doesn't work. Check the mode that you're in. Same on Packet Trace. If I type conft, that doesn't work because I'm in the wrong mode. What I got to do is type en. I'm going to press tab, press enter. That takes me to privilege mode or enable mode. This gives me a lot more power. Question mark. Notice I have more commands here. What do I need to use now to see one line of output at a time? The answer is enter. So enter shows one line of output at a time, or spacebar shows a whole page of output at a time. Same here. If I type enable, and notice here I'm not going to press tab. I'm simply going to type enter and put in my password. I didn't have to complete the command for the command to be recognized. You can use abbreviated commands in Cisco devices, switches, and routers. Really important that you learn to be lazy. Don't type the full command. But notice here, if I press question mark, I see a whole bunch of commands. Many, many commands. This is a real switch, so it has many, many commands. A lot more in privilege or enable mode than user mode. So we've learned about user mode. Allows us to do some show commands. You can do some basic things. One of the most important things is to move to enable mode or privilege mode using the enable command. In this mode, you still can't configure the switch. So to do that, you're going to use the command conf. So I'm going to type conf tab, which is actually shorthand for configure. And if I use the option question mark here, notice it shows me other parts to this command. So the only option here is terminal. So I'll type T tab and press enter, and notice the prompt has changed. Now we're in global configuration mode. Here we were in enable mode. Now we're in global config mode. By using the command configure terminal, we have now moved to global config. Here I'm in enable mode, type conf, and I'm not going to tab. I'm just going to do the abbreviated command, conft. Notice it works in this mode because I'm in enable mode, and I've now been taken to global configuration mode. If I use the command end, that takes me back to enable mode. On this Packet Tracer switch, type end, takes me back to enable mode. If you get output like this, you can just press enter to redisplay the prompt. Let's exit out of the switch. So I'm going to type exit now to take me out of the switch. So I've exited out of the switch. I'll do the same here. Notice it tells us that the console is now available. Press return to get started. So I'll press enter. I'm in user mode. Type enable or EN for short. That takes me to privilege mode. Type conft or configure terminal. That takes me to global configuration mode on the switch. On the physical Cisco switch, press enter. I'm in user mode. Type EN and I'll press tab here. That auto completes the command. Press enter. In this case, I've got to put a password in, and I'm in enable mode. Type conf, press tab, T, tab. That takes me to global configuration mode. I'll type exit to go back to enable mode, and I'll do the same on packet tracer and press enter here. Now you've got to type enough information to make the command valid. What I mean by that is if I type C in tab, the switch is complaining now because it says, what do you mean by C? If I press question mark at this point, notice various commands start with C. So it doesn't have enough information to auto-complete the command. So if I type CO question mark, there's still 3 commands that start with 30. So if I press tab now, it's not going to work. CON question mark, still 2 commands. If I press tab, it can't auto-complete. Hence me typing conf, because if I press question mark now, the only command that's valid is configure. Press tab, notice it now auto-completes. If I don't put in T and press enter now, it asks me, how are you going to configure the switch? Default is terminal, so I can press enter and notice I'm taken to global configuration mode. So again, I can't type CON. The switch is not going to like that because it says, it even tells us that this is an ambiguous command. If I type conf, now it sees it as a unique command and I can press enter to go to terminal. Same thing again, if I type end here and type disable to go back to user mode, if I type E, that's not going to take me to enable mode because it's not a unique command. Notice ambiguous command. EN, enter, works because that's the only option. So just to do that again, I'll type disable now, EN question mark. This is a unique command. The only command that matches is enable. So I can press enter, put my password in, and I'm in privilege mode. So in the real world, you obviously want passwords in your devices. I'll show you how to configure that in a separate video. Brand new switch is not going to have that necessarily. Depends on which device you buy. But on this switch, as an example, there is no default password. Okay, so at this point, we've got to global configuration mode. The only command I want you to learn is hostname. So if I type H question mark, that matches. So I can press tab. And what I can do here is give the switch a name like S1 and press enter. Notice the prompt. It's now changed S1. I previously configured the switch as C9200CX. I could go conf T and type host name, type the full command out. Question mark tells me that this is the name of the switch, and I could just say test. Notice the switch name changed to test. But actually, let's put it back to C9200CX, and notice the prompt has changed back to the name of the switch that I wanted. Okay, so let's do end here. So we're back in privilege mode. You could do this in user mode as well. So if I type disable here, I'm in user mode. If I type the command show question mark, a whole bunch of options are available here. I can show many things. S question mark, 2 commands match there. SH, 1 command matches. So I could type tab now to auto-complete the command. Question mark shows me a whole bunch of options. But what I want to do here is show you the MAC address table of the switch. So I'm going to type MAC tab. That doesn't work. So question mark here. Address table is an option. So I'm going to type A tab. That is the full command. If I use question mark here, there are other options, or I could just use carriage return, which means the command is ready to be used. So I'm going to press enter or carriage return, and notice it tells us there are no MAC addresses at the moment. No MAC addresses have been learned in this network. This is packet tracers. So these switches don't by default send traffic. In the real world, devices send traffic straight away. Like Windows devices are very chatty, so they'll send traffic straight away. If I type end here and type disable once again, so DIS, and notice it doesn't work because there is matching commands. So if I press question mark, I've got disconnect or disable. So I have to type DISA, press tab, enter. Now I'm in user mode, and I can type show MAC question mark address table question mark, whole bunch of options on a real switch. But the one I'm looking for is carriage return. So I'm just going to say enter now. And notice a whole bunch of MAC addresses are shown in the MAC address table of the switch, including what are called dynamic MAC addresses. And I can see that these MAC addresses will learn dynamically. In other words, the switch learns it when traffic is sent in the network on specific interfaces. So this MAC address exists on this interface of the switch, gigabit 1/1. That's this white cable here, and that's connected to this laptop. Hopefully you can see this white or grayish cable. That means that the Windows computer that I'm working on is connected to gigabit 1/1 on this physical switch. So if I open up a command prompt on the PC now and type ipconfig/all, we'll be able to see the MAC address of the switch. There is the IP address of the switch, and there is the MAC address. So if I look at the MAC address in Packet Tracer, that MAC address matches this MAC address Notice the numbers are the same, but this switch has learnt that this PC is connected to this port on the switch. In other words, port gigabit 101. Now that may be a bit confusing with all the different windows and stuff, so let's simplify it by looking at Packet Tracer. This is where Packet Tracer is great, keeps it simple. So on the switch, if I type show MAC address table at the moment, no MAC addresses have been learnt. When the switch boots up, it doesn't know where anyone is. It's waiting for the devices to send traffic into the network. So as an example, on laptop 1, I'll open up a web browser to our server. So if I connect to the IP address of the server, 192.168.1.3, and click go, hopefully the switch will learn where the MAC addresses are. And notice there, we've been able to connect to the web server, going back to our switch. Remember before, no MAC addresses were displayed, but typing the command again, I just used up key there. Notice we can see the MAC addresses of the devices. The switch has learned that PC with MAC address 001, a bunch of ones, is connected to gigabit 101. In other words, this PC is connected to this port. And if we look at the PC again, let's close the web browser, go to command prompt and type ipconfig/all. Notice that's the MAC address of the PC, physical MAC address. The switch has learned that this PC is on this port. It's also learned that the server is on port 3. So let's just confirm that. I'll open up a command prompt and type ipconfig, should be ipconfig/all. Here's the MAC address of the server. It's learned that this MAC address is on gigabit 103. There's the MAC address in the MAC address table of the switch. There's the MAC address on the PC. And here's the interface number, 103, gigabit 103. What the switch hasn't learned yet is the MAC address of laptop 2, because laptop 2 hasn't sent any traffic. We've only got those two MAC addresses in the MAC address table. So let's go to the laptop, go to desktop, open up a web browser and browse to 192.168.1.3, click go, server displays. I can access the web server, have a look at the MAC address table of the switch. Before we only had 2 MAC addresses. Notice now we've got 3 MAC addresses. PC1 is connected to gigabit 101, PC2 is connected to 102, and the server is connected to gigabit 103. Switches learn where devices are in the topology by learning where the MAC addresses are. When devices send traffic, the switch learns where those MAC addresses are and then forwards the traffic only out of the relevant ports. This is different to a hub, which again just floods traffic out of all ports, except the port in which it arrived. What happens if we move the PC? So what I'm going to do is delete the link here, go back to the switch. Let's have a look. It says the interface has gone down. So the switch is intelligent enough to know that that interface is not available anymore. Press the up key, enter to show the command again. So I'll do that again, up key, press enter. It's now removed the MAC address of PC1 from its MAC address table. If we connect the switch to a different port, so I'll get a copper straight through cable, connect the PC to, let's say, gigabit 1010, different interface. What the switch should do now is learn that the MAC address is on that port, not on 101. You need to wait for this to go green. Again, spanning tree is used in networks to stop loops. We'll cover that in much more detail later. You're just going to wait for that. The switch has learned that this interface has gone up. If you can't see the prompt nicely, simply press enter to display the prompt again. So switch 1. I'll press the up key again, press enter. It hasn't learned where the device is yet, even though this is green. So again, press enter. Nothing's displayed for that PC because it needs to send traffic. And actually what's happened for me is all the MAC addresses have been removed because they time out after a period of time. So on this PC, let's close the command prompt down, open up a web browser and go to 192.168.1.3, press enter. Web pages are displayed, press enter, up key on the switch, press enter. Notice it's now learned that this MAC address is on gigabit 1010. So my topology diagram is wrong here. If I go to options, preferences, show port labels in logical workspace, you can see the actual port is 1010. So I'd have to update my label here to make it correct. So I'll go back to options, preferences, change that and make this 10. The switch automatically learns where devices are when they send traffic into the network. That information is stored in the MAC address table. In the old days, this was called a CAM table or content addressable memory. Don't worry about that. MAC address table is the term that you need to know. Or if you see CAM, that's an older term. But there you go. It's learned where those two PCs are. If I send traffic from this laptop again, so I'll open up a browser and go 192.168.1.3, what should happen is the MAC address table of the switch should be updated, and there you go. We can see PC1 is on gigabit 1010, PC2 is on gigabit 102, and the server is on gigabit 103. That was a practical example of a switch learning where devices are in the topology. Using its MAC address table, it will only send traffic out of specific interfaces rather than out of all interfaces like you would have on a hub. I'll demonstrate that using simulation mode in a separate video where we can see the difference between a hub and a switch. But for now, hopefully you've learned a little bit about the interface of a Cisco switch. Cisco switches run iOS these days, either classic iOS or iOS XE. We'll talk more about the operating systems that Cisco switches use in a separate video. You've learned about services on a server as an example. You've learned about MAC address tables on a device. This is only the beginning. Hopefully it's not too overwhelming. Have a look at the video again if you struggle. I will repeat a lot of this in the course. Repetition helps learning. You'll get this. Just keep on studying.